Begin. All right, team. So we're on exercise 10E. Like I said, this session is going to be pretty easy. You're just needing to read the graph and how to get the graph by plotting coordinates. That's it. Now let's fill in some spots here. So when I had you this term at the start of the term, we went through linear equations. So it was y equals mx plus c. And that just basically means your graph, when you plot all the coordinates, they will then look like a linear or straight shape or straight line shape. Okay? Whereas today, we're now in quadratics for the last 5 weeks or so now. We've worked on chapter 10 and we worked on chapter 8 where I talked about factorizing was one of the key points. Now we're going to visualize it. You're not going to learn how to sketch it per se using algebra. You're going to learn to sketch it plotting coordinates. That's why it's relatively easy. So here, what is this called? This graph has what we call a parabolic shape. So write that in. So when they say, what shape is it? It's parabolic shape, or the type of shape we call it is parabola. Okay, so I'm going to write here parabola. And that's what I'm going to show you on Desmos today so that you can see. There are some key features that you need to know, and that's what the exercise is about, is just identifying some key points. And there really are only 3 key points, but they put in an extra term, so there's 4 terms to remember. Okay? Here we go. Let's have a look at a parabolic shape on Desmos as you copy that down. So it's linear. That's what you did in the early part of the term 3. Now we're on parabolic shape. So what if the pattern of coordinates looked more something like this? So right now, I just took an x squared. Okay, so anything with a square is quadratic. Anything with a square will give you a parabolic shape. Whereas without the square, you get a straight line. So if I took off that square right now, if I took off that square and I just typed x, that becomes a straight line. Okay, so x to the power of 1 is a straight line. But once you have an x to the power of 2, then you get a quadratic. As you go through year 9 and 10, you essentially learn linear and quadratic. And then when you get to year 11, if you happen to go with methods, then we do a lot more. We do cubics, quartics, and then obviously other polynomial functions. But at the moment, the most common is linear and quadratic. Okay, so x squared. There's a couple of features here. I want you to look at the picture. Can you see that if I pick the point 2, 4, which is up here, this is where 2, 4 is, and I'm just going to put the coordinates so you can see. 2, 4, that's the point on the graph. But what's interesting with squaring, so every time you square an x value, so if x was 2, 2 squared gives you 4. So the y coordinate gives you 4. But what happens is what if I did negative 2? See, negative 2 squared, what does that give you? What's negative 2 squared? 4. Negative 2 times negative 2 is still positive 4. So when I put negative 2, 4, thanks team. Please don't speak while I'm speaking. Watching, eyes and ears towards the board. What you see here is it's symmetrical. Both at x equals 2, when you square 2, you still get 4. And at negative 2, when you square it, you still get 4. So there's this mirrored image on the right-hand side and the left-hand side. Hence, this is a parabolic shape. So no matter what negative numbers you put here, it actually reflects and looks exactly the same on the right-hand side. So there has to be a center where it all sort of meets because it's all symmetrical up until a certain point. We call this point, which at the moment you can see, it's right at the center, we call that the turning point. So at 0, 0, you can see this is the point where it starts at the very minimum. So in your notes here, can you please write over here, you have 2 types of turning point. When it looks like this, minimum, whoops, let me just fix that. This is what a minimum looks like. That's a parabolic shape, that's a minimum. Boys, thank you. Copying notes, actively listening. So here we go. So when you have a parabolic shape that has the turning point on the very bottom, that's the minimum it can get. So that's the minimum. Whilst if you drew it the other way around, we call this a maximum. So that's as max as you can get Whereas this is minimum as you can get to the very bottom, and then you go back up. Whereas this one is as high as you can get, and then it goes back down. So you've got a maximum and minimum shape. The turning point, I already said, that is the point right up here. Well, in this case, in the picture I've got for you, that's 4, 6. That is your turning point. So label that so that you know what the turning point is. So 4, 6, so when x is 4, y is 6. 4, 6 is my turning point. That's where the shape changes its direction. So label that in. 4, 6 is your turning point. So turning point is 4, 6. Now the only new term they've added on, which is just for you to sort of understand, but we don't really use that language as often, but they will ask you at year 9 and year 10 level. Later on, you sort of just move on and solve for turning point. They call it the axis of symmetry. Shh. Boys, whatever you need to say, you can wait till I finish and then speak. It's rude. Here we go. So axis of symmetry. What is axis of symmetry? So I said in that shape, in that parabolic shape, there has to be a point where it's sort of symmetrical. Now it can be symmetrical horizontally or it can be symmetrical vertically. So where is that line? And they call it the axis because it's a vertical line. Axis of symmetry, and it always is where x equals to something. So I'll show you back in the graph again. You can see here the axis of symmetry is where I'm cutting down. That is how I'd cut the graph in half so it's symmetrical. If I'm cutting the graph in half, where am I cutting it? It's literally at x equals 4. So at x equals 4, this is what we call the axis of symmetry. X equals 4. Which you'll find that it's interesting that it's wherever the x corner of the turning point is, that kind of hints where the axis of symmetry would be. Because that's where it's a vertical line that cuts the graph in half. Hence we call it axis of symmetry. So all you're doing in this exercise, you can see you're really just labeling. So you're looking at a graph, they'll give you a whole bunch of graphs, and they'll say, what is the turning point? What is the y-intercept? What is the x-intercept? And then what is the axis of symmetry? Let's have a look at some examples. As you're copying this down, let's have a look at examples. Let's have a look over here. Back to x squared again. This is my graph. You've got the center right here. And you can see if I typed in x equals 0, that's where the axis of symmetry is. It's cutting it in half. If I go to the next one, let's have a look at the next graph. Let's have a look at this graph. I've given you a graph here, and if I asked you, what is the axis of symmetry or what is the turning point? You can see the turning point is sitting right there. That's where the minimum that it can get. So my axis of symmetry must be at x equals 4. That's where it cuts it in half. Okay, so x equals 4. So that's what I typed in. That's called the axis of symmetry. If I asked you to tell me the coordinates of the turning point, where is that point on the graph where it turns around? Well, you would have told me that is at 4, 0, because you're labeling the coordinate. So that's called the turning point. 4, 0 has two numbers there, an x and a y. And the axis of symmetry is literally where the x line cuts the graph in half. That's why I'm saying that it's easy to figure out if you know what the x coordinate of the turning point is. Okay? All right, let's have a look now. So you got axis symmetry, in this case, is x equals 4. You've got minimum or maximum. In this case, what kind of graph is this? Is it a maximum or a minimum? Maximum. So here you can then circle maximum to remind you this is a maximum shape. X-intercept, which we've learnt from linear equations. Looking at this graph here, where does it intercept the x-axis? Where does it intercept?
2, 0, and 6, 0.
Very good. We've got 2, 0, and then we've also got 6, 0. So when we say x-intercept, you will then write here 2, 0, and 6, 0. Very good. And lastly, your y-intercept. What's my y-intercept here? Where does it cross the y-axis? Looking at the shape. Anyone see it? Very good. So you got 2 x-intercepts, and then you've got 1 y-intercept on the bottom. Hey, Lucas. No, not appropriate. 0, -18. Thank you, team. Can you please just copy? The session today is that. That's all you're doing. So part of the session is you labeling. It's not even so much mathematics. Later on, you do have to calculate these, but that's a much later. That's in year 10. At the moment, you're learning to identify. So where's my turning point? Where's my x-axis intercept? Where's my y-intercept? And finally, what is my axis of symmetry? And that's what 10E is. So let's have a look at some examples, and you tell me what you see, okay? So these are the notes from the example they gave you. But let's have a look at some examples from your textbook. Let's do a quick one. So I want you to tell me, again, equation of axis of symmetry. So it always starts with x equals to a number. Turning point, is it a max or minimum? What is your turning point? X-intercepts and y-intercepts, okay? So I'm going to pick a couple of students here. Let's go with the first one. First graph here. Is this a maximum or minimum type of turning point? Minimum. So Mohammed, you've got minimum. That's good. So minimum. What is the x-intercept? Can I please have, let's go with Zach. What are my x-intercepts here?
1, 0, and 3, 0.
Beautiful. So we've got x-intercepts at 1, 0 and 3, 0. What is my y-intercept? Let's go with Estella. Where does it cross the y-axis? Very good. It crosses at 0, 3. So here we say 0, 3. So we've got 2 points there, but we still need a turning point. What is the turning point? Let's go with Jaden. 2, -1, which is over here. This is your turning point. 2, -1. So 2, -1. And the last one, which I find students tend to get wrong. So these 3 are easy. And then the last one, when I ask it, for some reason, students tend to get it wrong. I say, what is the axis of symmetry? Hands up if you want to have a go with this one. What's the axis of symmetry, Hadi? No. What's the axis of symmetry? 2. So this is what I was saying. For some reason, something about, all the coordinates everyone can get right. The axis of symmetry is literally the line that cuts this in half, and we can see it cuts it at x equals 2. And the hint that I told you just now was look at the x coordinate of the turning point. X equals 2 is what they want. So when they say axis of symmetry, which I will likely ask, you better be ready for that. Okay, some reason. It's just, they always get these 3, and then that one they always get wrong. Something about the big words. Axis of symmetry scares students. All right, next one. Let's pick another one. I'm going to pick this one over here. Let's do the same thing. Is this a maximum or minimum? Let's go with Ruby. This is a maximum type of turning point. What is my turning point? Can I please have Olivia? -1, 7. But yes, you're correct. That is at -1, 7. So we've got -1, 7. Very good. What is my x-intercept? Let's go with Jeet. X-intercept, what are you seeing? -4 and 2. Very good. So we'd write -4, 0 and and 2, 0. Very good. Next one. What is my y-intercept, Lucas?
What?
Y-intercept. Where does it cross the y-axis? All right, Lucas.
06.
Can you see this graph?
Yeah.
Yeah? This is the x-axis.
06.
Yeah.
There.
Crosses y. Right there. 0, 6. Okay? So here we go. 0, 6. Very good. And then your last one, which I said most students get wrong. What is the axis of symmetry? Let's go with Jake. That is correct, but I want you to say it properly. It's actually x. Very good. Okay, x equals -1. You must write the equation. All right, team. Let's move on to the next one. Go to your notes. Back to your notes. Can you go to the back of the page? We're going to do example 2 because now you can do example 1 yourself now. But let's have a look at example 2. Flip over, flip the page over. Here we go. Example 2. So what do they do now? So these are only 2 skills. One, identify the points like we just did. And then example 2, well, they might not give you the graph. You have to plot the graph yourself and then figure out where the x and y-intercepts and turning points are. So here, they give you the equation. They tell you this is the rule. They give you a bunch of x coordinates. Zach, eyes and ears towards the board, not towards Sam. Here we go. We got y equals x squared minus 9. They're saying, well, based on the rule, if x was negative 3, what would the y be? If x was negative 2, what would the y be? And you have to fill it out. So let's do positive numbers first, because sometimes students aren't really strong with their negatives. So let's start off with 0. If x was 0, then y equals to, instead of x, it's 0 squared minus 9. What is 0 squared minus 9 equal to? Minus 9. So I know this is negative 9 here. Let's do 1. If x was 1, then according to the rule was 1 squared minus 9. So I'm going to write that down. 1 squared minus 9. What is 1 squared minus 9? Can I please have, let's go Vaughan. What's 1 squared minus 9? 1 squared is 1, but then what's 1 minus 9? Okay, 1 you shouldn't be eating, so out you go, and I'll ask someone else now. Reese, what's 1 minus 9? Negative 8 is the correct answer. We've got negative 8. Let's go with the next one. 2. So hopefully you're starting to see the pattern. You can use a calculator for this as well if you're unsure of negatives, but we square it. 2 squared minus 9. What is 2 squared? Can I please have Steph? What's 2 squared? 4. And then what's 4 minus 9, Amelia? 4 minus 9. Negative 5. Very good. So we will then write here negative 5. Move on to the next one. Let's go with 3. Sam, if I want to solve for this one now, y equals, if x was 3, what would y equal to? Very good. Yeah. So this now gives you 0. Now this is a key one. I'm going to highlight it. Exactly. Why is this going to be key? Very good. Because the y coordinate 0. All right, next one. Let's go through the last 3. What happens when it is negative 3? So same thing. Y is equal to negative 3 squared minus 9. Now what's negative 3 squared? 9. And so 9 minus 9 gives you 0. So we know this is 0. What you'll likely see, there should be a pattern that starts to appear. Because remember, it's meant to be symmetrical, right? Let's try this one. What's negative 2? So y is equal to negative 2 squared minus 9. Negative 2 squared, what is that equal to, Ruby? 4, that is correct. 4 minus 9, and you'll find that the same answer occurs again. So you can see where I'm highlighting. These two are the same. Negative 5, negative 5. So even just looking at this graph here, what should be here? Negative 8. There's a pattern. So if you plot these coordinates down now, let's look at the coordinates. You have, whoops. If you plot the coordinates in, this is what you get. Negative 3, 0. That's the first one. Negative 2, negative 5. Second one. Negative 1, negative 8. Your third one. 0, negative 9. 1, negative 8. 2, negative 5. And lastly, 3, 0. All I'm doing is I'm just plotting x, y, x, y, x, y. Yep.
Wouldn't we only need the intercepts?
What do you mean?
Like to plot it out?
Oh, right now in this exercise, they want you to plot all the coordinates. Yeah. But yes, you're right. Normally we don't need to do it like this. Yep. Very good. All right, team. So let's plot these coordinates in. Hopefully you've done it correctly. Then this is what it should look like. Negative 3, 0. 3, 0. Where's that? Negative 2, negative 5. So negative 2, 1, 2, 3, 4, 5. Here we go. This is negative 5. Then you got negative 1, negative 8. 6, 7, 8. So negative 8 is here. Lastly, you've got 0, negative 9. So that's 0, -9. And then it's symmetrical. So you should find that it should end up looking quite symmetrical from what we got. So if I connect the graph now, what we expect is it should look something correct. And that's what you're doing. It's just what you did. It's what you did in linear. Instead of it being a nice straight line, this time it's parabolic. So let's answer the questions now. Let's do it again. Here we go. Axis of symmetry. What is the axis of symmetry? Can I please have, whom have I picked? Jake? Axis of symmetry.
-9.
Minus.
-9.
No. X equals what?
9.
Not 9.
0.
It's this line here. Where's this line? It's at 0. At x equals 0. This is what I'm saying. A lot of students get this one wrong every time. I put in a test and they get it wrong. It's where the x corner of the turning point is. It's always a hint. X equals 0. That tells you. So x equals 0. What's the type of turning point? Can I please have... Let's go with Jeet. Type of turning point, maximum or minimum? Minimum. Very good. Minimum. Coordinates of the turning point. Let's go with Steph. Where's the turning point? 0, -9. This is where it changes, so hence we call it 0, -9. Where's the y-intercept? Can I please have Hardy?
The y-intercept is 0, -9.
Correct. So in this case, turning point and the y-intercept are the same. It's still 0, -9. And then lastly, what are my x-intercepts? Let's go with Olivia.
0,
Very good. So right there, 3, 0 and -3, 0. X always comes first. This is your exercise 10E. Okay, so that's all you're doing. You're either plotting the coordinates, identifying, or you identify the graphs. Okay, that's exercise 10E. It's currently 9:26. I'm going to give you about maybe, let's give it half an hour. As you're doing 10E, once you're finishing the half an hour or whatever you can finish, I will then do some examples of a worded problem from 10D, and that's about it for today's session. Okay, don't forget, Thursday you will have an assessment on quadratics, chapter 8, chapter 10, so make sure to be ready.